Okay, so I thought maybe we'll cover a few what we might consider Pythonic features. I mean, we've already seen quite a few Pythonic features, some things about Python, especially in its object-oriented programming system, the Python data model that I think has really neat features, especially those double under methods. Um, but there's a few more things I wanted to cover in and so we'll take a look at them. Okay, I just pushed this commit to GitHub so you can do your pull upstream main thing to get the latest updates. Okay, so so one thing that is handy is something called a named tuple. Okay, we've already seen we talked about object-oriented programming and defining a new class and things like that. And sometimes, you want to define a new class, and the class is just like a very simple kind of structure that's going to be used to just kind of house content. Okay, so for example, one of the earlier classes that we defined was the point. Okay, and we said class point, and we created a kind of an initialized method, and effectively the class point just contains two values, a value for X and a value for Y. And then we also created a way to kind of print out the contents of point. Otherwise, we're going to just get that unintelligible result that says, main point at some memory location, which is never really handy for us. Okay. You could, if your class is really just going to hold values and not have like its own special methods, then you can just use something called a named tuple. And this is just going to be a very quick way to create some kind of object, some kind of class. All right. And so what you have to do is you do have to import the named tuple kind of structure here. And that comes from the collections module. So you'll do from collections import named tuple, and then you can just create a named tuple. So what we're going to do is we're going to create a point class named tuple that contains two values, X and Y. All right. And so we're going to just say point is named tuple, and we've got point X and Y. Okay, and that's it. All right. So the point contains two values, X and Y. The name of the point is called point, and that's it. Okay. And then so if you ask, well, what is point? Point is going to be this point object that exists in main. And now that we have it defined, we can create instances of it like any other class. So I can say P is point 1, 2, and basically 1 is going to go into X and 2 is going to go into Y. Right. And if I ask what is P, now it tells me it's a point class object where X is equal to 1 and Y is equal to 2. Right. And so this is kind of a very quick way to define a class, right? It's just done in one line rather than having to go through this whole process of creating a class. Okay, you can still create it this way. All right, there's nothing wrong with doing it this way, but sometimes because it's such a handy structure, sometimes as you're reading other people's code, you'll see this thing named tuple. I would say it's used moderately frequently, especially for kind of new classes, and it's handy. Okay, and so so now that we have an instance of the named tuple, then we can access the values just like any other class object using dot notation. And also because it is a tuple, you can use it using kind of square bracket notation as well. So you can do p dot x is 1, p dot y is 2. You can also do p square bracket 0, index 0 position is 1. Okay, and then it's also a tuple, so it's going to inherit basically all of the methods and operators and stuff associated with a tuple. So here I'm going to go ahead and define 3 points, 0, 1, 3, 4, 2, 2. And we can say, is P1 greater than P2? It doesn't really make sense if we think of it as a point in a coordinate space. But if we think of it as a tuple, then comparison makes sense, right? And so the way comparison does is it compares the first element, and it says is 0 greater than 3, and if that were a tie, then it goes to the next element. But here 0 is less than 3, so P1 greater than 2 returns false here. Okay. Also with tuples, you can add them together, and you will get a resulting tuple where these elements have kind of, this has extended the tuple, right? So this kind of method gets inherited from just tuples in general. Okay. And then a list can contain basically any type of object. So here I'm going to create a list L that contains objects P1, P2, P3, and we can see that if I print out L, it tells me this is the contents of L. And with the list, you can then do things like, can you sort it? And it sorts it, giving X higher priority than Y. So it's going to sort it, say, putting the X values in order, X0, then X2, then X3, and things like that. Okay. And then if you do need to extend the class definition so that, sorry, give me a second here. If you do need to extend the class definition so that it has its own methods, which is, you decide that and the named tuple is not, flexible enough, and you have to kind of create your own methods and things like that, you can then create a new class that just inherits from the already defined class. All right. So here we can create a new class called UberPoint or whatever it is that is going to inherit from the currently defined class point. Okay. So that works, and it's handy as far as creating classes that just store other values. Okay, let me go ahead and I will give you your first view quiz answer for today. Today's first view quiz answer is the letter A. A as an apple. A as an apple is your first view quiz answer. Okay. Today's lecture is just going to be kind of like a hodgepodge of different topics and stuff. Okay, each one being kind of like a short little thing here. All right, so we didn't get to this on Monday's lecture, but I wanted to talk about list comprehensions. And list comprehensions are super handy, and they just kind of form what basically you create a list as if you were running a loop. Okay, so here you can create a list comprehension like this. You basically have the square brackets that says you're creating a list, and then what goes inside kind of looks like a for loop, right? For value and collection. And so basically you have some expression for value and collection if with some condition. And this is basically equivalent to creating this following loop, right? You have some results starting off with an empty list, and then for basically for each value in the collection, you're going to check some if condition, and then and if it is met, you will append the list with whatever expression you have here. Okay, so let's just go ahead and take a look, right? So here I'm going to make a list of just squared values. So we're going to say x to the second power, x squared, for x in, and then the collection is range 1 through 11. Okay, 1 comma 11, which ends at 10. So range 1, 11 starts at 1, 1, 2, 3 up to 10, and it gives me all the scored values, 1, 4, 9, 16, 25, etc. Okay, and then again, well, you can also throw this into a Numpy array. So if I import Numpy, I can take the list and throw it into an array, and then we'll get the resulting Numpy array. All right, and this is basically a list comprehension, but thrown into an array, which is going to be handier. Although with Numpy, you could have just easily done range 1, 11, and then create a new array that does x, squared. So this is kind of silly, but the list comprehension can be applied to basically any kind of collection or list object, right? And then if you want to have some kind of condition, that also works too, right? So we can say, x squared for x in range 1 through 11, but we're only going to do it for the odd numbers. So we're going to say if x mod 2 is equal to 1, right? So if x mod 2 is equal to 1, then it will only score the odd numbers. So we have 1 squared, 3 squared, 5 squared, 7 squared, and 9 squared. Okay. Okay. All right, and then here we're going to also take a list of strings, okay? And we're going to write, so here's another kind of collection or iterable, which is a list of strings. And we're going to write the words that are over 2 characters long in uppercase. So we're going to take the strings. And so here we got A as bat, car, dove, Python. And then we're going to say the value that we want to capture is going to be x.upper for x in strings. Okay, so for each element in strings, so we're going to take for x in strings, we're going to take the uppercase if the length of x being how many characters we have, if the length of x is greater than 2. So basically only 3 characters and higher. Sorry, excuse me for a second. Okay, and so this is, I think, pretty handy, right? Because you can imagine any kind of collection or something, and then you can iterate over it. And a lot of times you want the results stored in some kind of list. And so if you just kind of restructure the way you would write a for loop, so if you can imagine writing a for loop, okay, then you can create a list comprehension, because you write a list comprehension almost in the exact same way you write a for loop, except the first thing that goes into the list comprehension is basically the expression or the thing that you want to store. Okay, so and you don't need to have a conditional statement if you don't want. Very handy. Okay. And this can be done with any kind of iterable, whether it's so far we've been kind of looking at range and list objects, but you can do it with tuples and strings. And so here's a string, and it says hello 963.257 world. And what we're going to do is we're going to say for x in string, right? So for x here is being basically each character in the string. When you turn a string into an iterable, every element is a character. And we're going to say for x in string, the thing we want to store is going to be take the string x and turn it into an integer, right? So we're going to take x and turn it into an integer if, and then we run x dot is digit, right? So if x is a digit, this is going to be returned true or false. We're going to do it. And so this will basically take any string that has digits in it, and it's going to extract out all of the digits and put all of those digits into a list. Okay. Here I've got a dictionary, right? And so with a dictionary, you can iterate over the items in the dictionary, or you can iterate over the values or the keys in the dictionary. And so here we're going to iterate over the dictionary's items. And so just in case you forgot what the dictionary items view object is, right? So here I've got d.items, all right? And this is basically all of the items arranged as a list of tuples, okay? So we have, a list with 5 tuples in it, and each tuple consists of the key and the value. So we've got A, apple, B, banana. So basically, this is the D items are the tuples inside here, and we can iterate over that, right? So here, this is, I hope you guys can read it. What we're going to do is we're going to iterate over D items, okay, D.items, and we're going to pull out key and value for key and value and D items. So key is going to be the letter and value is going to be the word. What we're going to do is we're going to create a string that says blank is for blank. And the things that we're going to feed in there will be the key and the value. So we're going to basically say A is for apple, C is for carrots, E is for eggs, and things like that. And we're going to do it if the key, okay, if the key is not in this tuple B, which contains B and D, right? So here I just put in some arbitrary condition here, and so we're going to iterate over this, and we're not going to do the B, we're not going to do the D, and so this is what we get. We get a list of strings that say this, right? And so you're limited only by kind of your creative imagination as far as what you want to do with a list comprehension. Okay. And similarly, you can create dictionary comprehensions. Okay. And so you can create a list comprehension which will create a list. Sometimes you want to create a dictionary comprehension, and it works the exact same way, right? Now you have two expressions. One expression is for the key and one expression is for the value. Okay. And then basically you're going to go for each basically item, I should say for item in the collection, if there's some condition, all right? And everything is put inside curly brackets here, okay? So here, I've got some collection here. It's gonna be a list of fruits. I've got apple, mango, banana, and cherry. And basically the thing that we're gonna go for in the key is we're going to go through each element in fruits, right? So each element in this list, F, is going to be one of these words, all right? And the key is going to be, we take the fruit name and we're going to capitalize it. We're going to take, make the first letter capital, okay? And then the value that we're going to do will be the length of letters in the word. So here it's going to be, we've created a dictionary where the first key is apple with a capital A, and the value is 5. The second, we take mango and we make it capital, we take the value 5. The third is banana with the value 6, and cherry, 6, and things like that, right? And so this is just a very simple expression, a dictionary comprehension, and you can imagine, whatever it is that you want for your key expression to be, or whatever it is that you want for your value expression to be. And you can go over and create a dictionary comprehension this way. All right, so here, just a couple more examples of this. I've got strings A, as, bat, car, dove, Python, okay? And one thing we can do is you can use enumerate, okay? And enumerate basically creates a list or an iterable of tuples where every element in here gets kind of paired up with an integer, right? It starts counting. It just starts counting, starting off at 0. And so it's going to say A is 0, as is 1, bat is 2, car goes with 3, dove goes with 4, Python goes with 5, and et cetera, et cetera, et cetera. Okay. And so now what we're going to do is we can iterate over this. So we can say, and basically, I mean, this is kind of silly. I could have just done dictionary on enumerate strings, but here, I can do it like this, where we can take the index and the value in enumerate strings. So we're basically going to unpack the tuple here into an index, which is an integer, and the value, which is the letter, and then we're going to create a dictionary where the index corresponds to the value. Index becomes the key, value becomes the value here. All right. And so this is going to be the resulting dictionary comprehension. Okay. But just as easily, I could turn it this way, right? I can take the, have enumerate. When enumerate gets unpacked, it's going to unpack the first element goes to index, and the second element, which is the word, goes to value. Okay. And now I can create a dictionary where the word that got unpacked, such as A or as or bat, becomes the key. Okay, so the key will become A, the key becomes as, the key becomes bat, the key becomes car, etc. And then over here, I have the index, which is going to become the value, right? So here, now we're mapping to the location, okay? And so here, what this can be done, how this is useful is if I have this index map, I can only look up basically its position. I could say, you know, what is the index 2 element? Index 2 element is bat. What's the index 5 element? The index 5 element is Python. But here, if I wanted to know, well, where is, what value, what's the index of A? Index of A, I can't look it up in the other dictionary. Here, but I can look it up here if I, with this dictionary, I can look up, you know, what's the index of element A? Its index is 0, right? So that's going to be a dictionary called location mapping here. If you wanted to, you can kind of combine both dictionaries using quargs, or you can just update one with the other, right? So here I can do this, and now all the words have their index, and then also all the index. Or, you know, likewise, I could also just do location mapping and update it when the index map, and everything gets combined. And so now, so you kind of, this is a little bit of a redundant dictionary, but you can look up A corresponds to 0, and you can also say 0 corresponds to A, you know, as far as this thing goes. Okay, any questions on this as far as list comprehensions or dictionary comprehensions go? And I believe Data Camp also has a course, or at least a chapter on list comprehensions. Let me see. Yeah, in the Python data science toolbox course, there are list comprehensions and generators in chapter 2 of the Python data science toolbox. Okay, and again, so this week your homework on Data Camp is to just kind of earn 2000 XP, which is approximately 2 chapters of a Python course. And which course you want to do is entirely up to you. I probably recommend doing a course on pandas, or or Matplotlib, but you know, whatever you want to do. Okay, let's talk about generator expressions. Generator expressions are similar to list comprehensions, okay? Except they are what we call lazy, evaluated lazily. All right, so I'll explain what the difference is here. Okay, so here I've got G is going to be a generator expression, and the only, you know, this looks a lot like a list comprehension, except here I'm using parentheses rather than square brackets, right? So if I put this inside square brackets, it would be a list comprehension. Here I've got parentheses. This becomes a generator. Okay, and so if I ask, well, what is G? It's going to say, well, G is a generator object, okay? And so range 12 starts off at 0 and goes up through 11. And we can ask, okay, well, what's the thing? So we go next on G, and it gives me 0. And then, so, you know, n starts off at 0. Then it goes 1 squared, then 2 squared, then 3 squared. What's next? 1. What's next? 4. What's next? 9. Okay, so every time we call next on G, it gives me the next element. And then you can iterate over it, and you can say for, you know, the next value in G, print out the value. And it keeps going 16, 25, 36, 49 up through 121. Okay, because as far as our generator expression is, it's, you know, just take the n value and square it. Okay. Okay, and if once you reach the end of the generator expression, if you call next on G, you know, you run into an error. It says, you know, there's nothing left. Okay, as far as G goes, it ended at range 12, which is 11. Okay, the last element there, you know, it starts off at 0, ends at 11. There's nothing after it returns 121. Okay, is that all right for a generator? And so you go, well, what's the difference, right? Why would I ever want a generator, right? The list comprehension just seems a lot like, let's go back. Okay, like this just seems a lot simpler, right? If I wanted to create a bunch of squared numbers, this just makes sense. X squared for X and range this, and it gives me a list, right? And then you just go, well, that seems way more convenient than having this business where I have to keep calling next. Okay, I have to keep calling next, and you go, well, That seems strange. Okay. Well, the key difference is that the generator is lazy. Okay, meaning when you create a list comprehension, it's going to evaluate the entire sequence, right? So if you say for range 1 million, it's going to evaluate all 1 million values. It's going to square them all, and it's going to store all of those things, okay? Whereas the generator is only going to calculate the next thing when it's asked to do so, okay? And so depending on what expression you have and how urgent it is that you need that value, you might prefer to use the generator over the list comprehension, okay? So this I'm taking from this website here, okay? So here I have a list comprehension and I have the equivalent generator comprehension. We're going to just take n times 2 for n in range 1000. Now this is a very silly example because this is so boring and simple, okay? But so the list comprehension is going to be a list, and the generator expression is going to be a generator, okay? And the thing is when I do this list comprehension, it's going to go from 0 to 999, multiply every single element by 2, and it's going to store them inside the list, okay? And so if I ask, how much space does this take up in memory? It takes up more space because it's calculated every single value for all 999 things, okay? Over here, it takes up less space in memory. I mean, not that memory is a huge concern for you guys right now, but it takes up less space in memory because all it is it's an instruction. It's an instruction to the computer. When you get asked for it, give me the number, right? So it's kind of just like you could imagine kind of two philosophies as far as getting your work done, right? Somebody says, I want you to give me whatever, all the numbers 0 through 999 multiplied by 2, right? And one person can say, all right, I'm going to do that, and they're going to evaluate every single number. And it might, depending on how big it is, it could take a while to generate all of those values and store them into a list and return it back, right? To write all of them down, okay? And then the other person says, well, do you need all of them right now? And you might say, well, actually, I don't need them all right now. But when I ask for it, I want it. And the generator says, yeah, no problem. When you ask for it, I'll give it to you. But if you're not going to ask for it, I'm not going to waste my time trying to calculate every single one of these things, okay? And so so here with, the difference is that with the list comprehension, you can say, well, what's the fourth element, right? The fourth element times 2 is going to be, the index 4 element times 2 is going to be 8. Whereas with the generator, you can't say, well, give me the fourth element in the generator because it hasn't reached it, right? It hasn't. It says, whoa, I can only give you one at a time, right? If you want to know what it is, you got to ask me 4 times, and then I'll give, or 5 times. I'll start with 0, and then I'll work my way up to 4, and I'll do it, right? And it doesn't take, like, the difference in time is the list comprehension. All the cost is up front. The generator expression, the cost just happens kind of iteratively here, okay? So, again, if you ask for G, it does this. If you ask for the sum, you say, add up all of the numbers in G, this is when it's going to run through and it's going to say, oh, he wants me to add up, they want the sum of all of the numbers in the generator sequence, and it's going to go through and it's going to sum all of them up and return it to you. Okay, so it'll do the work and it'll give you back the answer. Whereas as far as if you ask the same thing for the list, it would just give you the answer right away also. Okay, it's going to say, oh yeah, you wanted that. I had all the numbers ready to go and I can sum it up for you. Okay, so the list comprehension, the generator expression are similar. It's just the generator is what we call lazy, and it's only going to give you the next value when you ask for it. Okay, questions there? All right, let me go ahead and give you your next view quiz answer. Next view quiz answer is B. B as in bear. B as in bear. Okay, and then looks like we're going to finish a little bit early today. The last topic is I'm going to talk about Lambda functions, and then we're also going to talk about map. Okay, map is in the form of some function and some kind of iterable. All right, you take some iterable and you're basically going to map the function across every element on the iterable. You can kind of think of this as apply. In R, you have the apply function. If you're familiar with how apply works, map works in a very similar way. You've got some function, and it's going to get mapped or applied to every single element in the iterable. Okay, and that's what it's going to do. The object it returns is a map object, which itself is iterable. You can take the map object and put it into a list, and it's going to, evaluate all of those things and turn it into a list as well, and give you the all of the things. Okay, so a lot of these things, you can think of, so like the range object. The range object is like a generator expression. You can think of the range object as a generator expression in that, so a lot of times, you do for n in range, sorry, this is just going back, talking about the difference between a generator and a list, is if I, right, so if I say r is equal to range 1,000, okay, and I ask what's r, you just get this back, get this thing, right? And then you can say for I and r, print I, and then it's going to print all of these things out, right? We could have also, I could have also done L is list on the range object, okay? And then we can also ask for L, and it gives me like all these things, range. I should have just done range 50 here. Okay, and it gives me all of these things. But basically, it's not going to try to list off all of these things. If we wanted to ask, what's the sum of R, no problem, it can do that as well. But it's not going to bother trying to evaluate these things until it's necessary. So you can think of the range as that, but you can iterate over it. Okay. So similarly, when you ask for map, it's going to return a map object, which is iterable. It's like a generator. You can throw it into a list, and it's going to evaluate everything and throw it into a list as well. Okay, so anyway, the examples I'm going to use, we'll use a couple regular expressions. If you don't know anything about regular expressions, don't worry about it. I'm going to just do a very, very simple one. Okay, and so here I'm creating a function. And what we're going to do is we're going to replace spaces. Okay, and we're going to find any place where there is, so /s means space, white space. So whether that's space, tabs, returns, new lines, things like that. This just means anytime you see white space and multiple of it, the plus means multiple, one or more. So anytime you see like a whole bunch of white space together, just replace it with a single space. So if you see space, 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 just replace it with a single space, okay? And so this is a function, it's called replace space, and it's gonna just take some expression x, some string x, it's gonna apply this thing where it's gonna substitute multiple spaces with just a single space, okay? So if I have the string hello Alabama, but there's a whole bunch of spaces here between hello and Alabama, there's a space after Alabama, it's going to replace all of these spaces with just a single space, okay? And it's, the space after Alabama does get replaced with a single space, but it's a single space, okay? So this is the function here. Okay, so what we can do is we can take, here's a list of strings, okay? And we have hello Alabama, Georgia, 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 written 3 times, Florida, South Carolina. South Carolina has 2 spaces in between South and Carolina. And what we want to do is we want to apply this function or map the function onto every single element here. Okay? So I can just do for item. And so what we can do is we can map this. Okay. And if I mapped this, this would return what is known as a map object. Okay. And so we can just say, all right, go through everything and print out the item. Or, you know, if I did, I could also just take the map and return, put it into a list, and it creates a list here, right? So this, maybe I should have just shown you what the map. So the okay. So if you run the map on this, you get back what's called a map object, and this is basically a generator. It's a generator. It's not going to give you, it's not going to tell you what it is until it's asked for it. I don't think do I want to ask for this next? No, I will not do that. Okay, but you can ask, you know, kind of the next thing here, and so you got the generator there. You can iterate through the generator and ask for each item and to print it out. Okay, or you could just throw it into a list and you'll get all of the results here. Okay, so we have all of these things, and we can see it replaced the 2 spaces and multiple spaces here in Hello Alabama with a single space, and it replaced the 2 spaces in South Carolina with a single space. Okay, so that's the map function. Okay, the Lambda function is basically, in order to do map, I had to define this thing, right? This function that I defined, replace space, it's a very simple function. All we're going to do is we're going to just take some value x, and we're going to just replace, you know, multiple spaces, right? So this is basically the entirety of my function. It's basically one line there. And so here I can run the map, okay, and I'll throw it inside a list as well. And the function that I want to map onto the text, okay, so look at how I call this. The map function is the name of the function onto the text, okay? I'm running map the name of a function onto the text. This time I don't have to actually name the function. I can just create what's called a Lambda function. A Lambda function is basically a nameless function. It's an anonymous function. And basically it just says Lambda on some value x. What are you going to do? You're going to run this command, replace the multiple spaces with a single space on some text x, right? This is basically the exact line that's inside this function definition. We define this function, replace space of it on x. And here, basically, I don't actually have to define my own separate function. I can create a Lambda function, which is basically a nameless function, and it's going to achieve the same thing here, right? The Lambda function can technically be as complicated as it needs to be. It's basically any kind of Python function, except in general, you only want to use Lambda functions if the function is very simple. Otherwise, it can get confusing for someone else who's reading your code, right? Does that kind of make sense as far as how a Lambda function works? Instead of having the function replace space here, we're just creating the function definition right here inside the map, okay? And so we're going to do lambda x, okay? Basically, lambda is like almost like the name of the function. You know, the name of the function, what's the argument? The argument is x. And then what's the expression? Replace the spaces, all right? And we get back the exact same results here. So here I could do, you know, something similar. What if, you know, for every element inside the text, because we're going to map this onto the text, you know, we can do a lambda where the argument that comes in is going to be a string, and we can take the string and do title text to it, okay? So we can do that, and here it will turn whatever we have and do title text, which will capitalize Georgia and fix the poor capitalization on Florida and things like that, so that gets, you know, it gets fixed here. This one's only doing title case, so it doesn't fix the problems with the, the funny spaces or things like that. All right, so that's, so sometimes Lambda functions can be useful as far as like cleaning up text and things like that, because a lot of times, when you import text and you're just trying to clean it up, each function that you're trying to apply is a fairly simple thing, like fix the spaces, remove some punctuation, add title text and things like that. Okay, Lambda functions can be, again, as complicated as necessary. So here you can create a Lambda function with multiple arguments, okay? And then you have a colon, and then the function is going to, you have basically what is it that it's going to return, okay? So you don't actually have to use the word return. Basically, you've got the arguments coming in with a colon, and then the thing that comes after the colon is going to be the thing that gets returned. Right? So here I can actually create a function that takes in two variables, x and y, or two arguments, x and y, and it's going to return x plus y. Okay. And again, and in this case, it's going to get mapped onto each element inside the things, right? So here, when you do map and it has x and y, you need to have an iterable for x and an iterable for y. Okay. And so then it's going to map this function over every element in x, which is 1 and 100, then 2, and every element in y. So it's going to do 1, 2, and 3, and it's going to go 100, 200, 300. And here it's going to do the first element of each, 1 plus 100, then the second element of each, 2 plus 200, and then the third element of each, 3 plus 300. Okay. And again, these are just really, really basic functions, basic examples of Lambda functions. And truly, your Lambda functions should be basic. They should be basic, because when you write your code and you want to be able to understand what you've done with them, and you've mapped a function across some kind of iterable, you want to be able to understand it. And so if you have a complicated function, you should define that function, right? Like we did back here. So over here, we defined a function, okay? And you really only want to use Lambda functions if this function that you're going to define is very simple, okay? Only if it's like a one-line function, or, at best, two lines or something. But you don't want to do, I would say, don't do a Lambda function if you've got some kind of conditional statement or something like that, right? Let's say it's just something where you want to just apply the function to every single thing in there. Lambda function fits the bill there. A single line thing, and you're just like, it feels like a waste where I have to define an entirely separate function. That's the use case for Lambda. Anything more complicated than that, just go ahead and define the actual function, and that will help you avoid some headaches. Sometimes you read other people's codes and they got Lambda functions everywhere, and it's fine. It's just it's not fun to read. Okay. And so, these are, I think, common elements that you will come across when you read Python code. And just so, sometimes, you read someone's code and you're just like, what is this? And so hopefully this will at least put you in the right track as far as, discovering some of the things, right? So, so we've covered Lambda functions, list comprehensions, and generators and things like that. So, okay, that's it for today's lecture. Let me give you your last view quiz answer. The last view quiz answer today is C. C as in cat. C as in cat for your last view quiz answer. Okay, and we'll call it a day here. And then we'll see you guys on Friday. So have a good night, and we will see you then. Oh yes, okay. So I got a message in the chat. Right. So there was a question. It says, I earned 2000 XP on the first homework assignment, but it also gave me 2000 XP for all three. That was not intended. I was hoping Data Camp would give you 2000, and then next week it would, but that's not how I did it. But when I created these assignments, that's what happened. And so what I'm going to have to do is next week, probably on Monday, I will create another assignment for 2000 XP. Okay. Or I think this homework is due Saturday. So maybe I'll create one on Sunday. I'll create another homework assignment for 2000 XP, and you'll have 1 week to do it. And then after that's done, I'll create another assignment for 2000 XP. So earn 2000 XP this week in week 8, earn 2000 XP next week in week 9, and then we'll have another 2000 XP in week 10. Okay, and we'll do it like that. Okay, that's all. Have a good night. We'll see you guys on Friday.